Good morning, everybody. Thank you so much for participating in today's roundtable discussion. I'm Assemblymember Linda B. Rosenthal. I represent the 67th Assembly District, which includes the Upper West Side and parts of Clinton Hell's Kitchen in Manhattan. I'd like to thank John Jay College, especially Jeremy Travis, the president, and Mindy Bockstein, executive director of External Affairs, for helping us set this up in this beautiful, beautiful room in this beautiful new building, and for helping my staff with a lot of logistical details. So I don't have to tell all of you, but 3D printing is pretty revolutionary. The applications are nearly innumerable, and when I think about what we can do to harness the potential of 3D printing, I am overwhelmed. And that's why I've invited all of you here today to help the state of New York better understand 3D printing, what it's capable of, and what we can do to help it grow and succeed. So with the advent of 3D printing technology, there are some basic fundamental questions. What are the current ranges of use of the technology? What are some of the future revolutionary applications of this technology? In what ways does 3D printing create new opportunities for business and consumers? Are new or different incentives needed to promote this technology? And what is within our grasp in the near term and in the future? It's important to explore not only the impact that widespread use will have on general consumer markets, but also the need for incentives and/or regulations to help promote the technology. At the same time, we must protect consumers and manufacturers. So as chair of the New York State Commission on Science and Technology, I believe it is imperative that the state play a constructive role in promoting the positive impacts of this technology. We must ensure that the industry has all it needs to not only survive, but to thrive here in New York State. And New York State must play a critical role in furthering this development. At the same time, in cases where such technology could potentially do harm, everybody's familiar with the world's first operational firearm produced entirely through 3D printing in Texas, as even though it's not ready for prime time, it's a harbinger of things to come, and the state must act to protect its citizens. Were that to come to fruition. So the aim of this roundtable is to explore what role the legislature can play in supporting this technology while protecting the safety and interests of the public and enhancing the opportunity for business development. So I thought we'd first go around and everybody introduce yourselves, and then we will keep the discussion going. I will just lay out how we're going to proceed. So why don't we start with Tina?
My name's Tina Trinkler. I'm with a new Dumbo, Brooklyn-based startup called 3DP Media. We are a startup that's really focused on trying to pull together the community around 3D printing. There's so much going on in the New York City and New York State area. And when my partner Land Grant and I first got together, we just realized there's so much information and it's really difficult to find out what's going on. So our first goal was, let's see if we can aggregate all the news, everything that's going on, the events. So we started with a website. We're also a little mini think tank, and we're an event producer. So for the past week, we've been conducting what we're calling the NY3DP Summit. And that was a series of events bringing together, similar to what Linda's doing today, a panel of experts around different topics. First of all, we explored the idea of economic development and jobs in neighborhoods. Secondly, we looked at sort of revolutionizing manufacturing and the idea of reshoring. We then spoke with a bunch of educators, mostly K through 12, but also at the college level. And then yesterday, we were participants in a Design for Manufacturing Summit. So we've through the expertise that we've been listening to in the last week and over the last several months, have sort of formulated our ideas and thoughts about what's going on currently and where we think things are going. I'm also separately a product development consultant, primarily in the area of toys and games. And my experience with originally rapid prototyping was 15 years ago at Hasbro, where we would prototype all of our games and our toys. So, starting there, and then a couple of years ago, as the technology started to become more mass market, I've been following it closely and very interested in where it's going.
Thank you. Next, we have Sarah Gerritsen, who's been of immense help to me and my office when I was named the commission chair, and I thank you for that.
Thank you. I'm Sarah Gerritsen. I'm the president of ITAC, the Industrial and Technology Assistance Corporation. And we are the New York City node of two main networks. One is the Manufacturing Extension Partnership, which is a nationally funded and promoted effort to grow and strengthen U.S. manufacturing. So we're very much promoting the reshoring, but the way that we work across the system is to focus on helping the SME, the small manufacturing enterprise of 500 employees or less, to both grow their company through innovation and to achieve operational excellence so they can be competitive. We've been interested, and our interest, I think, lies with 3D printing as one of a set of tools, which we talk about as being the additive manufacturing tool set, of which 3D printing is one. And then also looking at this as part of even the larger, which is the advanced manufacturing tool set. These together are going to bring about major changes in the way that the manufacturing companies operate and give them a whole set of new opportunities. I would call your attention, Thomas Friedman wrote a very good op-ed piece and really wrote it in English, which I loved. I mean, really straightforward, called When Complexity is Free. And it was about 2 weeks ago, and if you haven't read it, it's a really good explanation of what the potential is. So whether you're GE, which is what he talked about, and trying to make complex parts using 3D printing, or you're an entrepreneur who's just getting started and has an idea for a product, both kinds of corporate entities are going to be looking at 3D printing as a tool and for escalating innovation. On the other hand, it's a journey, and we've just started this journey. I mean, when the internet came about, I think many of us kind of scratched our heads and had no idea where it was going to go. And it's gone, I think, far surpassed the wildest imagination of many of us, anyway. The second thing I would say is that these are tools, and they're tools that put into the hands of the people who are creative, that it enables them to make complex products and parts, to tighten their supply chain, and to do more locally.
Thank you. Next, we have Melba Kerman.
Hi, my name is Melba Kerman. I'm an author, technology analyst. My background I worked at Microsoft for several years, marketing technology products to regular people. So that's been a really great background for the work that I do now, which is trying to take complex technologies and make them interesting and make sense of them to intelligent non-experts. So it's a real pleasure to be here today. I think I'm the only one here from upstate. Is that right? But I've been in New York a long time, and one of the things that I find really exciting about 3D printing is that I actually think New York City and New York State are uniquely poised right now to become a hub for 3D printed manufacturing. And the reason I say this is that I've been traveling all over the country, and actually sometimes the world, in the past year, after co-authoring Fabricated, a book on 3D printing, and basically just going around everywhere to speak about it. And the energy of the events on the East Coast, particularly New York, are very intense. And there's not that same intensity and high energy, even in Silicon Valley, where I was just in San Jose 2 weeks ago. So I think there's a combination of the manufacturing history, the legacy, the roots here on the East Coast, particularly New York State. And then there's this wonderful blend of designers and a big research base. New York State has some of the most research, largest number of research universities, I think, in the country. And so there's this convergence, I think, of forces that make New York uniquely ready to become a hub for 3D printed manufacturing. So in terms of public policy issues, one of the things that I think is great is that 3D printing has gotten a lot of attention lately because of the production of a 3D printed firearm. One of the things I think is not great is that 3D printing has gotten a lot of attention recently because of this 3D printed firearm. So my sense is just like any complex platform technology, whether it be the internet, the computer, even the automobile, 3D printing is going to have a transformative effect on life as we know it. And like any tool, like you were saying, it can be used for good and it can be used for bad. And my concern with the sudden, very intense concern over the 3D printed weapons is that it's basically jumbling a whole lot of complex regulatory issues into one sort of hot button, fear-based issue. And so what I've been trying to do is untangle in a meaningful way for people that in terms of public policy and regulation, we need to sort of take a step back and break down the tangle, untangle the tangle. And the way that it's been sort of gelling in my mind is that 3D printing enables a new sort of manufacturing, which is consumer to consumer. This is the MakerBots, the Shapeways, the Thingiverse, and I like to call this C2C. This has its concerns, in particular in terms of consumer safety, but there's no malice there. Another overlapping circle is the extension of professional manufacturing. And this is actually professional manufacturers creating 3D printed products. And there's things like material standards, does this product behave as it's intended? And that also has no malice. And I think that that's also something we can solve by extending the current framework. And then the third one, and this is really where the bad guys are, is terrorism and crime. And so my sense is that these three different zones are all being jumbled into one big mass by this sort of fear-based news. And so even interestingly, the 3D printed gun, that was not the act of a terrorist or a criminal.
Right.
This was a law student in Texas who I've met him. He's incredibly determined, very intelligent, and he was determined to make a functioning gun to prove a point. Yet, this is, I think, a really good example of how this particular incident has now been blown up into this sort of generalized fear or, jumble of, oh no, 3D printing's got to be tightly regulated. Maybe we should ban it. And I think this is my concern, is I think we need a framework and some sort of meaningful way to parse all the issues. And then we can start moving forward with very hopefully lightweight oversight.
Well, that is part of what I want to explore today, because yes, everything you mentioned is relevant to today's discussion, and we'll get back to that.
Thank you.
Thank you. Cody Burke?
Hi, so I'm Cody Burke from MakerBot Industries, and we're a Brooklyn-based 3D printing manufacturer, and one of our sort of early, less aesthetically pleasing models is sitting over here on the table. We've been around since 2009, and we really started as a, servicing the hacker, sort of maker, early adopter movement. Our first two models were kit-based, and then starting in 2012, we've really moved into focusing more on the professional prosumer market, we like to call it. And that's been our biggest growth area, and that's the most exciting area for us right now is starting to really sell into enterprise environments and design firms, architects, aerospace, automotive. And we're just hearing incredible stories from users about how they're using the technology to shorten design cycles and save money on prototyping and just speed up the iteration process. It's just unleashing a lot of creativity. And then just on a more sort of normal person level, we're seeing a lot of interesting stuff happening where people are adopting the technology for home use or for artistic endeavors. people starting small businesses using the technology, using it as a way to sort of jumpstart that prototyping process and kind of remove some of the barriers to entry for people. So that's been really exciting for us. And then education is another area that we're just tremendously excited about seeing and learning what students and teachers are doing with the technology in the classroom, and that's just been very exciting for us. We have some, we don't just have the printers, we have a sort of a 3D printing ecosystem, and that's really important to us, and that's kind of where we see the industry going. Is you have the printer, but then we have our website Thingiverse, which is sort of the default 3D content repository on the internet, and it's a free platform. Anyone can upload things, download things, remix things, and that's just a tremendous part of the company and really important to us, to our sort of core values. So we see a lot of interesting things happening there in the file sharing aspect. We also recently launched a scanner, so we have the Digitizer desktop 3D scanner, and that's a really exciting piece of technology that we haven't even started actually shipping that yet. So we've just been taking pre-orders, but it's been pretty well received, and we've had some press days around that and showed it off a little, and it's very exciting. So. All these issues that people have already raised, that they're all very legitimate, and there's a lot of discussion that needs to happen around them. And I think I wanted to thank you. I think this is a really good sort of step to that. One of the things that we really want the outcome of this to be is that when these sorts of issues, come up in government, that all the people at this table, and we need to be the resource for that, because there is a lot of hype and there's a lot of misinformation out there, and things can get blown out of proportion. And sometimes we need to sort of pull it back to earth and have those contacts to reach out to the people in the industry to get a clear picture of what's really going on. So thank you.
Thank you. Next, we have Frank Spinelli.
Hello, my name is Frank Spinelli, and I'm an engineer for Consumer Reports. It's a nonprofit organization that tests and rates consumer products. So it's a very fun place to work. So aside from product testing, I actually do quite a bit of lab setup, to collect all the data that we use, and that's originally how we got involved with 3D printing. Some of the test fixtures require some custom parts, so we actually started with the MakerBot Replicator 2X for some custom parts, but because the buzz has been getting so great, we wanted to actually just kind of get our feet wet with the technology and see what was out there. So I got an excellent opportunity to evaluate a small sample set of what's on the market. We ended up with the MakerBot Replicator 2X, a SolidDoodle 3rd generation, and 3D Systems CubeX. And when you get a quality print, it's one of the most rewarding experiences that you can have. It's so exciting. But the truth is, during the testing process, there was quite a bit of troubleshooting sessions, from heater errors to a bent heat head, the extruder. And a lot of failed prints. So there is some technique to learn, and it's not as seamless as just plugging this thing in and printing. And at the moment, it's still an investment. Could be up to about $3,000, but even as cheap as $500. So we want the consumer to know that if you're going to buy this, it's still best suited for that do-it-yourself personality, maybe engineering students, entrepreneurs, and that you really are going to thrive if you have those skill sets, even as simple as soldering or some drafting skills. CAD isn't, the computer-aided design isn't essential to be able to print, but if you really want to get the value out of your printer, you're going to need some of that. I don't know if the person from AutoCAD is here, but we're really pleased to see that they're offering some free solutions, being Tinkercad and 123D. So it's great tools for someone to dive in and get used to this technology. And that being said, is like the printers themselves, we feel, is just a small part of the equation. What really I think is going to make this thrive is kind of introducing these skill sets of drafting and engineering skills that we need to get in almost at the high school level for people to really be successful with 3D printing at the moment. And really excited about technology, and we hope it takes off. On the consumer level, there wasn't too many real issues that we thought could be raised, but there was a safety concern of some of the parts being pretty hot. And of the 3 printers, it was a large range of kind of quality of the product, let's say. So the SolidDoodle was more of that real do-it-yourself. I mean, even built with some hose clamps, and it was really wide open. So you could get your hand in there and actually hurt yourself. The MakerBot and the 3D Systems, they did a better job of enclosing it, and it was less of an issue. But another issue is the melting plastic. So you do smell some fumes when you're printing, and from what we've read, it seems to not be an issue, but I would love to hear a little bit more about it if that's going to be a concern going forward. And, you know, one other thing that I thought could take place is like reliability of prints. So if we could have some sort of standard to put these things through and vet them to say, okay, this is a printer that you're going to get a quality set of prints X amount of times, or some techniques that could produce a higher rate of success. So hopefully the discussion goes some of those paths, and I'm very excited to meet all of you. So far I'm having a great time, so to the next.
Thank you. And Professor Adam Scott Wendt.
Hello, I'm Adam Scott Want from John Jay. I'm an assistant professor of public policy here at the Department of Public Management. I have been studying 3D printing and its abilities for about 2.5 years right now. About 2 years ago, I went and I presented in front of the Academy on Criminal Justice Sciences about 3D printing and the inevitable issues that will come out of 3D printed weapons. About 2.5 to 3 years ago, we were already starting to see 3D printed weapon schematics appearing online on websites that house 3D, schematics. So we went out and actually we built that MakerBot. That was, I guess, John Jay's first venture. Thank you for the kit. We were very excited that the prices came down so low. Because before that time, before these cheap consumer 3D printers, it was cost prohibitive to get into 3D printing for research purposes, because the 3D printers cost tens, if not hundreds of thousands of dollars. So we were lucky to be able to build one of the earlier MakerBots, the Cupcake, and really start doing some research on what the potentials of this technology could be. And what we really realized is that these technologies are increasing and thriving really at an amazing rate. If you look at that machine's just 2.5 years old at this point. And the original machines were printing with PLA or ABS. I was fortunate enough to go to Maker Faire at the New York Hall of Science this weekend, and to see it should have been called 3D Fair, is what I was telling people, because to see the incredible number of 3D printing projects were at that fair were absolutely incredible. And one of the things that stands out to me as a researcher is that today we have basically the infancy of 3D printing, where we're printing with certain plastics such as ABS and PLA, but as time goes forward and as our machines become more capable, I think that the consumer, and as you said, the prosumer models, they'll be starting to print with other types of thermoplastics and eventually metal alloys that are much stronger than what we're printing with now, and that will, I guess, unleash an entire new type of concern for us. At the Maker Faire, I was very impressed to see it wasn't an extruding machine that printed like the MakerBot, but it was basically a homemade machine that used carbon fiber, and it was able to spin carbon fiber at rapid rates and make almost any sort of tubular product. And if you think of putting these technologies together, if you're able to spin and use carbon fiber, if you're able to use resins or high-impact plastics or metals, I think that it's definitely the right time to look at this from a policy point of view, because there's no doubt that New York City could be, or maybe even already is, the hotbed of the 3D printing industry. It's absolutely incredible, to start seeing pop-up 3D printing stores in downtown Manhattan. It's a great place to live, just to walk around and see all this stuff. But from a policy point of view, what we're really concerned about is how the government and the state should look at 3D printing from a policy point of view, because if one thing's clear, there will be some policy issues that need to be dealt with, but they need to be dealt with in a way that allows the 3D printing culture to thrive. We definitely don't want to have policies here that are retroactive and scared of 3D printing, proactive policies that the industry could propagate and that the industry could agree on, proactive policies that are able to deal with some of the, I don't want to say it's the darker sides of the issue, but that's kind of what it is. But for them up front to be able to deal with some of these darker sides of the issues and come to consensus about what is good and what is not so good early on, I think that if people could work around the same table now, it will save us a lot of grief later on. Because proactive policy, from my point of view, is much better for technology than retroactive policy that's passed, you know, after people get upset or after their incidences. And I mean, just to close with the capabilities of this technology, so this is a small wheel gear that we've printed using our MakerBot. The MakerBot could print a 4x4 square. 4 inches times 4 inches. So nothing we can print out of that machine could really be larger than a 4x4 unless we're going to snap it together. But just to show you how impressive the technology is, we're using the small machine to print a larger machine. And you know, across the street in my lab, we're actually making a machine right now that will be able to print 1 meter by 1 meter. And the fact that the majority of, not all of them, but you know, a majority of the components are coming from things that we're printing ourselves. That really says a lot about the capabilities of the technology when eventually it might actually be able to replicate itself in one way or another, although there are certain limitations there that are obvious. So thank you for inviting me to this roundtable and hosting it at John Jay College, and I hope that we could be of some use.
Yes, thank you. Thank you. I think we're missing a couple of people. We're waiting for one of them, but I think we have a good assortment of qualified brainiacs here to have this discussion. So I thought what we'd do is break this roundtable into 3 parts, each consisting of general questions. And the 3 general questions will be, what is the status of 3D printing now, and where do you expect it to, this field to go in the future? The second is, what will be some of the impacts of this technology on New York City's economy and image as a leading tech hub? And finally, what public policy issues do we need to address when thinking of this technology? And I think all of you touched on these themes in your introductions. So I thought we could, I would just put out there, what is the status of 3D technology, and where do you see it going in the future, both near and long term? And I guess, Tina, you and Land Grant were at this week-long summit, and maybe you could explain some of the themes that emerged during the week.
Sure. Happy to do that, and definitely chime in or add or or negate if you disagree with anything that we've been hearing. But the way that I see it, and what I was hearing on our various panels, is there's really 2 directions that things are going. Maybe riffing a little off of Melba's comments, but there's the home-based DIY market that MakerBot is serving, and others that are making the machines that the consumer is going to use. And then there's also a lot going into more of a commercial-based market, like Stratasys, who's in the local area, where they have much more expensive high-end equipment where you can send a design in and they'll print it. What you get from the different machines are different levels of quality, but where those things are going to go in the future is I believe, very different. There's been a lot of hype, in my opinion, about the home-based machines, and a lot of people, thinking that this means that everybody's going to print everything that they ever need at home. My personal opinion is that's not so. And
will never be so?
I don't know, 10, 20 years from now, is the technology going to be such that, it's the Star Trek replicator?
Right.
Maybe. But I don't think it's going to get rid of the need for retail as we know it, or mass production as we know it. So one of the themes that was coming through loud and clear from a commercial perspective is that while 3D printing has the ability to start to create or enhance a small business marketplace of small batch manufacturing made in diverse locations by individuals on a made-to-order basis, which really changes the product supply chain, that probably is not going to impact Walmart or, you know, the things that we buy in bulk. So there is that, and for me, that's a very exciting area to explore, and I'm excited to see where that's going to go. But on the other side of the equation, 3D printing is really going to become a part of other manufacturing processes. So we're seeing, and I think Sarah can talk more to this, but what we're seeing is that a lot more companies are now able to much more quickly prototype products. They can actually test them in the marketplace, so you don't have to make a million before you find out that it fails. And they also manufacturers are starting to use 3D printing to do things like create the molds for their manufacturing process. Just as a little information, there is a company called Bechtel up in Rochester, who is a injection molded plastic company. Normally, to make a mold for that process, it takes about 8 weeks. You start with a large hunk of steel, and somebody drills into that steel. And if you mess up and you go too far, you got to start over again. It's very expensive. It's very time-consuming. They are now printing their molds. They can do this in a matter of a number of days. It now drastically reduces the production process as well as the cost of doing that, and then brings down the cost of making the products. So from that perspective, it can start to bring manufacturing back into the States, where things have been offshored previously. So other areas where there's been very, very interesting progress, and I'm certainly not an expert, but I've been following it in the news as much as I can, is medical, dental, architecture, and some other areas where they're really looking at using 3D printing as a within the context of treating the patient. From a dental perspective, they're looking at, taking a scan of a tooth or a bridge or whatever is needed and producing it right then and there, versus you go in, they take a mold, you come back in a week or two after it's been produced. Same thing in the medical industry, and in talking with a few physicians, they're very excited about the possibilities there because it really does change things drastically. So the third thing that 3D printing really lends itself to is this idea of customization.
What would the prices be, or how does that affect the cost? Because, well, everything is greatly inflated right now, but if you're designing and printing something, covering my molar that's broken with a brand new one, what are there any discussions about how the cost is affected?
I personally don't have that data. Maybe one of the other panelists might, but from my gut feeling is that you're either having a machine there that's producing it for you, where the material costs are very cheap, or you're sending out and having somebody custom make it for you in a lab. So from a dental perspective, I would imagine, unless anybody knows differently, is that it probably, once you amortize the cost of the machine,
Right.
the cost per unit is probably cheaper.
Would you like to comment on this?
I can't speak to
Not this,
dental
but-
and medical
No,
per se.
but in general.
I
Yes.
think I liken it to 2D printing, right? Just to look at what's happened with that. That 25 years ago, you'd send your document to a factory-like printer where they would typeset it, and they would print it, and they would collate it, and they would put it together, and they'd send it back to you. Okay, so that's like a traditional manufacturer. Then we went into Ginkgos, right? We took stuff to Ginkgos. Well, UPS is starting to move into becoming the Ginkgos of 3D printing. They want to be putting 3D printers into all their storefronts eventually, I think. And they've started with their first. So that's kind of exciting. Brings 3D printing to the neighborhood. Then, now we all have them on desktops. So I do think that at some point, you know, we'll have it on desktop. And I'm going to sort of talk about it in terms of, so I've got a refrigerator and part breaks down. Right now, you have to go online. It's made in a factory. It comes back to you. Maybe at some point soon, we'll be able to take it to a local hardware company that'll have a store that'll have a 3D printer, and they will make it for you. Eventually, you'll get to the point where you make it yourself on your own printer. And so I think the question is, it's going to happen, but when is it going to happen, and what is it going to take to make it happen? And I'm not that kind of forecaster. I would say the second thing is that with the risk of being politically incorrect, I think technology is kind of moving at such a rapid pace that for more mature people, this is often hard to keep up with, to figure out, to master. And so from the perspective of manufacturing firms in our state and in our city, we have a lot of them that are run by people who are on the more mature side. So unless they've got a crew of young people within their facility, they're not necessarily reaching out and looking to embrace this technology tomorrow. It is younger people who think that it's really cool and are comfortable enough with the technology to bring it into the company and play with it.
Do you have any comments about this generally?
I do. I think just to put some numbers onto it,
Yeah.
the estimated global market for 3D printed goods and services and 3D printers sold in 2012 was roughly $2 billion US dollars. And so just to put this into perspective, the GDP for mass manufacturing in the US was about $3 trillion. So if you were to model these as balls, you know, one would be the size of a beach ball, the other would be smaller than a ping pong ball. So with that said, I think it's important to realize that 3D printed manufacturing is tiny. It is growing fast. It's growing at roughly 25% growth rate a year. And tiny in manufacturing isn't necessarily a bad thing, because if you look at the demographics of the manufacturing firms in the U.S., over half of them employ fewer than 9 people. So even a small pie that's several $billion can go far when it's distributed amongst these very small service providers. In terms of jobs in mass manufacturing, 3D printing is not going to take away mass manufacturing. Never. People like to say that, you know, mass manufacturing is going to go away. We're going to make everything at home. I don't see that happening. Where I see 3D printing emerging is one, it's a tool to aid and accelerate and you know, grease the wheels for product development, mass manufacturing, like you were describing. And then second, there will be the emergence of new industries, particularly personalized medicine, any high-margin products where there's a market of one. This is housewares, jewelry, things like that. And then I heard a very interesting talk. A biotech company called Organovo is printing tissue, but not to make new organs. You know, that maybe someday, but they're printing tissue because 3D printing enables tissue to survive, and then it can be used for FDA trials, toxicity testing. And so we're at the very beginning, and I think if you let technology loose into the hands of creative people, there's going to be all kinds of amazing new business models that are going to emerge. And so, but I think trying to just swap out one paradigm, mass manufacturing, with another, 3D printed manufacturing, is absolutely the wrong way to think about it.
But that is the way a lot of people who just have a surface knowledge about it are worrying. And so what is there to tell them? Why will it never replace, the big manufacturer model?
So mass manufacturing is very efficient, it's very cost effective, and it's a really good way to make large numbers of identical products, whether it's a car, whether it's these things. If you need to make large numbers of a product where it's okay that my product is like your product, that's ideal for mass manufacturing. And for those of you who have ever been fortunate enough to visit China or actually see a mass manufacturing facility, just the size of a warehouse room filled with gigantic machines that are furiously stamping out millions of identical objects.
Yeah.
People don't realize the speed at which things are mass produced, and then the global supply chain at which they're shipped around. But where 3D printing is ideal is in making objects where you do want it to be custom. And this
Right.
is why, in terms of 3D printed products, the first inroads have been made in the medical and dental industry and in the art, the high-end art and home housewares. So, I mean, if people ask, is this going to do away with mass manufacturing or jobs, the answer is no.
Okay.
And the sad news is what takes away jobs is automation, factory automation.
Right.
But that's not 3D printing.
Okay, yeah, I think I've read articles and I've heard people express concern that this will take away jobs, especially low-skilled jobs, because the people who operate these assembly line operations won't be needed. But you're kind of saying that's not so.
Yeah, if I could chime in there as well. Although some things come out of the printer all in one piece, like that wrench that you have there, that's not the case for everything.
No.
And it also doesn't come out looking beautiful and fully decorated and all the other things. So the idea that you're just going to, print it and poof, take it out, and that's the
Right.
final item, that just isn't the case. So there's still all of the back end steps, the finishing, there's polishing, there's unless you've got a printer that has 12 heads on it and is printing on multiple colors, there are probably paint steps. There are all the same things. There are assembly. You have to add in electronics, although there are some printers that are starting to print circuit boards and things like that. So it doesn't take that away. There are still those jobs that are going to be required to do all of the rest of the steps. Packing. The printer isn't going to print the packaging.
Right,
It's-
right.
Could I
there-
chime in on that for a second?
Yeah.
I think that a lot of what we're talking about is the realistic nature of today. And that today, under no circumstance, is 3D printing getting rid of large-scale manufacturing jobs. However, one of the things that I recently saw at, again, Maker Faire, which I was quite impressed about, was a new generation 3D printer that was a combination 3D printer, milling device, laser engraver. And they built, these three very different technologies into one box. And while I think that today we don't have to worry about loss of manufacturing jobs, and tomorrow we do not have to worry about loss of manufacturing jobs, I think that there is an inevitable future of this technology drastically changing the way we consider gross manufacturing. And I mean, yes, it might be very easy to gross manufacture, 20 million screws, but it's not very easy for me to leave my office and go to Home Depot to buy one. And I think that eventually that push and pull that we will see, and we're not talking about 1 year, we're not talking about 5 years, we're talking about the near future. But I think eventually what that push and pull we'll see is a market-based equilibrium where 3D printing or its future generation will be able to deliver certain products that make sense to deliver, but you're not printing out a car or a refrigerator, or at least for the very, very near future. So I just wanted to add that.
Yeah, so I think that when you're talking about sort of the effect 3D printing can have, particularly on businesses, like the positive effect, we just had we have a retail store down in Soho, And we hosted a night with the architecture firm, Perkins & Will, major architecture firm. And the gentleman who came in and spoke talked about how they had started using MakerBots for that. I mean, that could be any, 3D printer of that sort of price range. And they'd saved, upwards of 90% on their 3D printing costs. Previously, they would send things out, it would cost, $400, $500 to get it back. And maybe it would get back the next day, maybe it would be a few days for a client meeting. And now they're doing it, for $5 of plastic, and they can do it overnight. And so there's incredible cost savings that businesses like that, and that speaks to that very specialized. I mean, an architecture model for a presentation with the client, they only need one, and that's the only way to do it. Before they would have, previously, a while ago, I mean, someone would have actually had to build the things. And some first-year architect would have been there all night doing it. So, so that's a great cost savings, and then they can take that money and use that in other parts of the business. There's a company called Level Up. I think that's the name of them. You've probably seen them in coffee shops, and they have the little, you sort of tap your phone to pay for your coffee. Well, they released a new version of that unit, and they used a MakerBot again to do the prototyping for that. And they estimated that they saved $30,000. And so that, at a startup, that's an entry-level job right there. That's another staff member that they can hire. So in companies like that, this can have a real benefit on their ability to grow a company like that and to move faster. And for a startup, that's a huge deal. Moving into the more manufacturing area, one of the things, and just to be clear, MakerBot was acquired and recently merged with Stratasys, who you mentioned. So I've been working with them as well, and they make much more high-end, expensive systems. And one of the interesting things I've noticed from my interactions with Stratasys customers and with Stratasys itself is the amount of 3D printing that's used in jigs and fixtures in manufacturing processes. So this isn't the idea that you're making the final product, but making custom parts to manufacture the final product. 3D printing is often, perfectly good enough for that, where it wouldn't have been good enough for the final product, but you can build your assembly line using custom 3D printed parts. And that's an absolutely massive market. And just at the Stratasys plant, where they make the actual, printers, they are printing parts to make their own printers actively in the factory. Hundreds of parts are being made that way. And we're seeing that in automobile manufacturing, where they need certain special parts on the line to do certain things, and it changes every time a new car model rolls down the line. So being able to do that as opposed to have that milled is a huge advantage for them. Another interesting area in the manufacturing space that we're seeing a lot of too is bridge parts. And so that's the idea that if I come up with a prototype for something and then I want to test it in the market, I want to make this product and see if it sells, instead of spending all that money to get the tooling made to get it injection molded, I could start manufacturing the first run of that product. Using, if you wanted to say make a new, you thought you could improve this design, you could create that model. I could 3D print this easily and cost effectively for the first run, for the first couple hundred, and then I'm like, oh wow, it's selling. Now it makes sense for me to get this injection molded. So it removes that barrier to entry to the market for people. They can get products into the market faster, and so that's a key area. The one other thing, I sort of wanted to touch on, you're talking about sort of the where we're at in terms of the consumer market and people getting them, everyone, having one at home. One of the questions people ask me a lot are like, people try to find something to compare it to. They're like, is this a microwave or is this a Kindle? Is this in terms of adoption rates, like what's happening? And I think it's probably more of like a blender. You don't use it every day if you had one at home, but you might use it once a week, and you're glad you had it.
But will it always be a blender, or?
Depending on how the technology advances, there's a lot of benefits to mass production of those goods. There might be some things that are appropriate to do in the home like that. But the other part, even if it doesn't make sense, I mean, I think people have forgotten how to be creative, and we've had mass production in the previous industrial revolution that has sort of beaten the creativity out of us. And there's something, you spoke to it about, there's something really tangibly satisfying about making something on a 3D printer and designing it and printing it out. And even I moved into a new apartment recently, and I'm replacing all the light switches in my apartment with 3D printed ones. It doesn't make financial sense to do that. I can buy them cheaper at a store. But I get to make glow-in-the-dark ones for the hallway to my bathroom, and I get to make ones with a little hook for the door where I can put my keys when I come in, and it's really fun. And there's a real you know, you get a little buzz out of doing that. And so I think that, you know, particularly for home use, it doesn't have to make sense. It can just be a lot of fun. And who knows where that's going to go, you know, as people get more creative with it.
I have a comment about that. So from a consumer standpoint, you just touched on it. It's as much as I'd love to see what you said, maybe manufacturers would give plans for a broken replacement part. How financially, it almost can't make sense. You know, these parts are costing a lot more to print than you could get from a company that has stockpiles of these parts because they're building them, you know, with like injection molding. But it's like, what would your return on investment be? It's like, it's tough to imagine that these printers could have a business model like paper printers where they almost give the printer itself away for free and they monetize with the inkjets. I can't imagine that you guys are going to monetize with the plastic, right? I mean, so you're never going to get to a point where these printers are kind of given away and the supply is what makes you money. So I don't know, is there any plans with that? I mean, it seems to be kind of a...
When you look at the high-end systems that are used in manufacturing, the requirements on the finished parts are such that there's a lot more value in having more of a controlled consumables model, particularly if you're talking about, you know, some of the higher-end Stratasys machines create finished end-use parts that go into planes and automobiles, and if that's where the final product is going, then you really want to control that consumable supply chain so that you can ensure the quality of it. On the MakerBot level, you know, it's not as important, and it's not as big a part of the business model. But on the high end, it's more of an element of that. Yeah.
Just responding to one of Corey's points, I have a blender. I've never used it.
So do I.
I have some college friends, however, who use their blenders every single day. So you know,
Yeah.
who knows where it will end up in the
Yeah,
long run.
yeah. No, believe me, I get the weirdest questions like that
Yeah.
about microwave blender,
Yeah,
Kindle,
makes sense.
laser disc. I hope not. You know?
Okay, so so I think we've covered a bit of question one. Question two would be, what will some of the impacts of this technology be on New York City's economy and image as a leading tech hub? And you mentioned how there seems to be so much more energy on the East Coast and in New York in particular when it comes to 3D printing. So maybe you can start by addressing that.
Well, I think, it depends on what industry you're printing for, but there's been a lot of very interesting, high-profile printing in fashion.
Yes.
And New York is, of course, the fashion capital. And so I think that has already given a great boost to the image of New York as this tech-forward sort of city. And I think that people should keep doing that. That's a good thing. I think in terms of the less visible, more utilitarian type manufacturing, that's where we go upstate.
Like where?
And there's unfortunately rust belts up there. That for those of you who have ever been to Buffalo or Syracuse, you know, people are really struggling. And I think that's where it's harder to change. And where you can't just change a mass manufacturing base into an advanced manufacturing base quickly or easily. But I think that New York is already on the map for fashion, design, housewares, that sort of thing. But I think an unexplored area is medical research. So New York, there's probably with Boston, if you have to go see a specialist, you want to go to either one of these two cities. And 3D printing is already doing very well in advanced manufacturing in the biotech and medical device industry. And so since 3D printing is unique that it's small footprint manufacturing, you don't need to go and set up this huge warehouse or center with a lot of different machines in it. I think one area that New York is really ripe for is advanced manufacturing in the medical industry. And the research is here, the specialists are here, and you can 3D print very advanced medical devices and explore tissue engineering in a room this size. You can get a lot done. And so that would be my hope, that can be addressed or explored. But just one last thought, going back to the less cutting edge manufacturing,
Right.
I really think you make a great point about making sure that the education continues for the people who are already skilled in traditional manufacturing, and somehow making sure that they're getting on board with this new digital manufacturing. Because it's a big leap, and it's a leap that if you don't make it, you're never going to cross the chasm.
So do universities offer, I mean, I'm starting to think that maybe every public school needs to have a few 3D printers so the kids are prepared not just to see it and think about it, but to actually use it and see that this is a field they could go into.
We do, we have some, kid-focused events that we throw down at our store, and it's insane. I mean, they go crazy,
Yeah.
and they get it. They don't ask questions about
I
it.
know.
There's no, it just makes
Yes.
sense to them.
Yeah, yeah.
And they pick it up incredibly fast.
But
and
it's
just-
not part of any school curriculum in terms of K through 12
Some,
at
some,
all.
yeah, I mean, some schools, yeah,
Some
absolutely.
STEM
We have
related
a
schools
curriculum, a MakerBot curriculum page where we work with NYU Poly and some other schools to sort of help teachers develop curriculum, and then they roll that back to us, and then we provide it for free on the website. And other companies are doing similar projects, and the idea is to, the curriculum is the hard part, I think, particularly when you might have a teacher that doesn't fully understand the technology.
Right.
They just know that there's the buzz and they should start providing it. So, so it's something that we're working on, and a lot of other people are definitely, working down that.
Yeah,
way, I think.
we had a session Wednesday night with a group of educators who are using 3D printing in their curriculum, along with a bunch of people in the audience who were interested in it but didn't quite know what to do with it. And
Yeah.
many of them are using the MakerBot Foundation's curriculum as a starting tool. What we heard loud and clear from them is that 3D printing is only one of the tools in the toolbox for teaching, and that the biggest piece of it is really not the printing itself, but it's the design piece. And that, as part of STEM or STEAM education, if you want to add art into it, they really felt like it was important to make it less about mechanically you do this, you do this, you do this, but more about what they're calling design thinking, starting to learn how to think for yourself and have it project-based and goal-oriented. So, create a water bottle that has the lid on the bottom. I'm making this up. It's
Right.
silly, but,
Right.
How would you go about doing that? And the beauty of 3D printing from an education perspective is that, again, they can put it together pretty quickly. They can fail fast. And the other big thing that they said is that traditionally in our education system, failing is bad. They want to get rid of the term failure. They want failure to be a part of the process because you learn more by failing. So one of the key takeaways for us about education was that, and that they said, they very bluntly said that the design software is not quite where it needs to be yet. So.
Okay.
There needs to be a lot of work there, and that is one of the stumbling blocks for everybody is how do you build the CAD model so that you can make something cool and actually have it print properly. But
What grades was this in at the
this was K
university?
through 12,
K through 12,
and
okay.
we had both public and private schools represented. We also had a panelist from SUNY New Paltz. They have a new certificate program
Right,
there
right,
that they're promoting.
right.
That's their
Yeah.
brochure right there.
Yes.
I think that's the first of its kind
Okay.
in the state, and it really seems like a direction to me that things need to go. Because the more people learn how to design, the better they're going to be able to feed the market for 3D printing and its capabilities in the future.
I mean, in our public schools, sometimes we struggle to have Wi-Fi. People are now trying to make sure every student has a computer, a laptop, or they're trying to do tablets now. I mean, so we're pretty far behind, it would seem to me. Yeah.
And MakerBot's actually doing a great job with curriculum. You guys are doing beautiful stuff, but I actually had the opportunity to co-teach a course that was a week long. It was on the Cornell campus, and it was at high school kids. whose parents shipped them up to Ithaca
Yeah.
for 5 days and said, we want to get you interested in engineering and design. And these kids had zero background.
Yeah.
They were not self-identified techies. And so we set up a course where within a week we would get them to be selling a product on Shapeways. And so what I saw was a huge hook was telling a high school kid that, look, in a week you're going to learn a very simple design software. You're going to name a product, you're going to brand it, and you're going to pitch it to your peers, and you're going to sell it on Shapeways. And if someone buys it that you're not related to, then you've done really, really well. And there was something about selling it on Shapeways that made it real. And so they couldn't just kind of shuffle through and do some, the fact that it was going up for sale and then they
It was in the real world.
it was in the real world, and the beauty of it was that the design software was free. It was launched in 3D by Autodesk. And if you use Shapeways, you don't have to own the printers. You can upload the design file onto the service, and you pay for the materials. But you don't have to invest in 3D printing infrastructure or whatever. But there was something about selling it at the end that really made people pay attention.
Did people buy?
One of the kids turned out to be a real talent, and he made these really unusual pencil holders that was sort of the scalloped, interlaced cup, and you put the pencil sideways, and he turned out to be a success. As would be expected, half of the objects were really something only a mother could love. but the beauty of it was a couple of these kids I don't think would have identified themselves as product designers.
Right,
And they had a
right.
talent
Yeah.
doing this. And I
Yeah.
don't think you could do that in the old ways. Old design software, old manufacturing tools.
Yeah.
It was really fun.
I wanted to actually go back to the upstate, downstate,
Yes.
because I think New York City is a hub of creativity, that the entrepreneurial ecosystem here has just blossomed in over the last couple of years with much investment by the city, and it's having incredible results. But what we see is that people are creating products and using 3D printing and other technologies in order to do that. But then when it really comes to scaling their manufacturing, traditionally there's been a tendency to turn towards China. And there are a number of consultants out there who will facilitate that process. And we're interested particularly in trying to create New York State-based supply chains that will enable them to be made here. And we've done a couple of these, and we're seeing some success. So we've got a company here who's created a product. It's got a technology emphasis. There's a company in Syracuse who's actually making it for them as they scale up their manufacturing. So I think it speaks to real estate is always an issue here for manufacturers. So if we can create the higher value added parts of the business enterprise, then we can enable more activity going to some of the more traditional companies upstate. So win-win for both.
Yeah, I mean, when we think about economic development upstate, we turn to casinos and
Yes.
other kinds of things, but as you're all saying, there are limitless possibilities with 3D printing that a lot of that could happen upstate.
And upstate, because of low real estate costs, among
Yeah.
other things, has managed to maintain an industrial base capability, which we've in some ways lost in the city because companies have been driven out
Right.
because of the cost.
Yes,
cost
we've gotten rid of manufacturing zones here. Everything is residential, or it's becoming that way. At
It's-
least old
feels that way.
manufacturing zones.
Yeah.
It is that way. Yes. Did you want to comment about the educational?
Yeah, I had actually just two quick thoughts.
Yeah.
I was very recently discussing with another academic how technology is stifling the creativity of our children.
Yeah.
And one of my responses to him had to do with 3D printing, because we're already seeing, and it was already just brought up here, 3D printing art programs for kids. I have a close family friend who's an artist, and she teaches art at it's a fairly well-funded private academy in Westchester. However, they, once a week, they have a cart that rolls from classroom to classroom, and that cart has 2 or 3 MakerBots on it. The school is lucky enough to be able to afford laptops for the children, so it's very unique. But during, every once in a while during their art period, the students design their imagery, their artistic project in a 3D program, and then one at a time print it out with the MakerBot on the cart. And I think that's an excellent example of how we're already trying to use 3D printing to engage our children. But from a higher education standpoint, 3D printing is incredible for the math, sciences, and engineerings. It's already being used, for example, down at Baruch College for some of their engineering classes, and up at City College for engineering. So it almost instantaneously fell its way into higher education. And I'm very happy to hear that MakerBot actually has curriculum websites, which I didn't know until now, but ways to really help include this, because we need to start inspiring our students to understand these technologies so that they could use them themselves, as they go through higher education, which is great.
We have I just yesterday, I was up in Boston, and I went to Northeastern University, and they've just opened or it's not even opened yet, they're building out a 3D printing lab there, and it's more of a service bureau model within the school. It's in their library. It's very prominently just in the library. In there, they have a floor that's devoted to all sorts of technology, mostly computers and things like that. But it's in this sort of glass-walled room, so you can see into it. And they have they're building this collection of different machines that have different capabilities. They have some Stratasys machines. They have some from 3D Systems, another large company. They have a couple MakerBots, some scanners. And the idea is that the students will be able to go to a web portal and upload files, and then go pick up the print, in a few days. And so they're going around to the different departments and engaging with the professors and saying, hey, this is available, and here's some ideas on how you can work this into your curriculum. So they've gone to the architecture department, and they've said, hey, if you want your students to, understand this new technology, give them an assignment where they have to print out the final, and engaging the engineering and the art departments as well. So it's really exciting, and they're not even open yet, and they're already just it's glass, so it's kind of like a fishbowl. So the students just stand there and stare at them while they're setting up the machines. But they're predicting being over capacity the minute they open. I mean, and it's I'm not sure if there's other universities that have a similar program. A lot of universities have the printers and have sort of more like maker labs where people can go in and play with them themselves. But this is more of an actual service providing the service to them. And they're hiring a full-time 3D print tech to run it, and then students will be able to apply to work in it under Workstudy. And so they'll actually get experience running a 3D printing service bureau within the school. It's really exciting.
I have a question about that. So I'm
Sure.
all for the education
Sure.
stuff, but I'm just curious if there's a discussion about how to solve a problem of, obviously the design thinking is where you want the kids to learn, but I think the payoff, especially for young kids, is the product that's printed. And I've experienced print times of over 8 hours and failed prints. And what is the solution to give the payoff to these kids? Is it a queue? Do they want to be there when the printing's happening? And how many printers would you need? And just kind of a discussion of what that seems to be a problem in the education level that I would wonder if anyone's discussed yet at all.
But will it, I mean, the times are getting shorter and shorter, right? Or that's going to take a
The
while?
technology is getting faster, but there's a limit. I mean, this is nearly a day of printing. I mean, this is an extremely long print. But they are getting better. But yeah, that'll always be an issue. The time.